Good morning students, welcome back to the online classes in physics for standard 9th. Hope all of you are fine and are reading well. Last class we discussed some equations of motion and I had told that in the next class, that is today, we shall try to do some numericals to understand the concepts taught. Before we proceed for solving numericals, on the board you can see some summary. It's important to revise the contents taught so far. First one you can see regarding slope of xt graph and vt graph. If you remember slope, how do we find? By dividing the two parameters given. So this becomes delta x upon delta t. X is position, delta x is change in position, that is called as a displacement. So this is displacement by time, that is nothing but average velocity. Likewise slope of vt graph is ratio of delta v and delta t. Change in velocity by time, you know students, that is acceleration. So that is the answer. Here you can see there is a graph. There are two graphs, 1 and 2, and the question that is asked here is this: which of the two graphs has greater slope? First thing that you should see that both of them make acute angles and both the slopes are positive. In such cases, it's very easy to decide the slope which is greater just by observing the two angles. Slope of that graph will be more, which makes greater angle with x-axis. Here graph 1 has greater angle with x-axis, so the answer to this question is graph 1. 2 has lesser slope or smaller slope, 1 has greater slope. You can also understand this quite easily students by imagining yourself sitting over an inclined plane like so. You must have enjoyed such a ride on the sliders. Usually we find them in the parks. If you wish to slide out of these two, in which case do you think you will slide quite fast? In 2 or in 1? Of course 1. That's why 1 has greater slope. If you have different inclined planes like this, you can compare their inclinations. Here if you try to slide, will you be able to slide? No, because we say it has zero slope. Here the slope is something and here the slope is large. So just by observing the angle made with x-axis, you can guess this slope. Here graph 1 has greater slope. We will need such concepts while solving some numericals based on graph. Next was average speed. You know average speed is total distance traveled by time taken, and average velocity is total displacement by time taken. Area under velocity time graph, you know, that gives you, for slope we were finding the ratio, for area we multiply them. So velocity into time will be displacement. And then at last, very important 4 equations for uniform acceleration. Uniformly accelerated motion means here you must take a to be constant. The equations are like this: v is equal to u plus at, s is ut half plus half at square, v square minus u square is 2as, and s is equal to v plus u by 2 into t. All these equations we had derived using graphs last class. Just to remind you, what is u? U is initial velocity, v is final velocity, s is displacement, a is acceleration, and t is the time. You should note students that these equations you should never apply in such a situation when acceleration is not constant. What do I mean by that? I mean that you cannot use these equations every time. Only in such situations where acceleration is constant can these equations be used. If acceleration is not constant, that means if acceleration is changing, you should not use any of these equations. They will be wrong. So having summarized these concepts, let us proceed for solving some problems based on them. Okay, here is the first question students. Similar question I had also discussed earlier. A body covers half the distance with average speed v1. You have to assume straight line motion. So in its path, half of the path it covers with average speed v1, and the remaining half of the distance it covers with average speed v2. So if the body is moving from A to B, it is given that it moves from A to M. What is M? M is the midpoint of the path AB. So this half of the distance it covers with average speed v1, and remaining half it covers with average speed v2. Find its average speed for the entire journey, that means from A to B. I will take the distance from A to B as 2d. If you wish, you can take d also. In both cases you will get the answer. I will take it as 2d. I have to calculate the average speed from A to B. Average speed from A to B, you know the students' formula, total distance by time. Now what is the distance from A to B? I have assumed it as 2d, so I will write 2d. Now what is the time to move from A to B? We don't know, we have to calculate. For that, what I will do, I will take the time to move from A to M as t1, and from M to B the time will be t2. In answer I should write, let t1 and t2 be the time to go from A to M and M to B respectively. So t1 is from A to M, the time, and t2 is the time to move from M to B. So here the total time will be t1 plus t2. Now to find t1 and t2, what we need to do? We need to consider the motion from A to M and the motion from M to B. Now you see, from A to M, average speed is v1, time is t1, and this distance will be how much, can you say, students? This is half the total distance. Total distance was 2d, so this distance will be d. So our formula for average speed becomes average speed v1 is equal to distance d by time t1. Same thing we have to apply here. If this is d, this distance will also be d. The average speed for the second half of the journey v2 is distance, that is d, by time, that is t2. Now to find t1 and t2, we'll use these relations. So t1 will be how much? That will be d upon v1. And what will be t2? T2 will be d upon v2. So we will put these values of t1 and t2 over here. So this becomes 2d upon t1, I will write as d upon v1. T2 I will write as d upon v2 is equal to 2d upon d, I will take common, 1 by v1 plus 1 by v2. So d will cancel. So what will be left? 2 upon, we will take the LCM v1 into v2. So this will become v2 plus v1. So this gives us the final answer for average speed for the entire journey as twice of v1 v2 upon v1 plus v2. Is this method clear, students? If it is clear, let's proceed to do next question, which will look identical, but there is an important difference. Let's see the second question. Okay. Now this we have second question. It reads like this: a body travels with average speed v1 for half time, and for the next remaining half of the time it travels with average speed v2. You have to calculate the average speed for the entire journey. Assume the motion to be in a straight line. Suppose the motion is from A to B. What this question says, it travels for some time, say t. After time t, it is at point some point m. And then from M to B also the time spent is same, that is t. But these distances are not same because the average speeds were different. From A to M it travels with average speed v1, and from M to B it travels with average speed v2. So I take the distance from A to M as d1, M to B as d2. Now as I told you, is this question similar to last question, previous question? It looks similar, but it is not. There the two average speeds v1 and v2 were for half of the distance. Here it's not distance, it's half of the time. Their two distances were same, d and d. Time we have taken t1 and t2. Here it is just the opposite. Here time is same for both the parts of the journey, t and t. And the distances are different, d1 and d2. The method will be same, students. The average speed for the entire journey, v average. How will we write the formula? Total distance upon time. What is total distance? If this is d1, if this is d2, it should be d1 plus d2 upon. What is total time? T plus t is equal to d1 plus d2 upon 2t. Now this I can write as, what is d1 plus d2 by 2t? I can write it separately as d1 upon 2t plus d2 upon 2t. 2 I can take in the denominator as common, so this becomes half. Is it clear? Half you separate, then d1 by t, d2 by t. Tell me, students, what is d1 by t? You can see here, for the motion from A to M, what is the average speed? v1. What is the distance? d1. What is the time? t. So v1 must be d1 by t. And the motion from M to B, if you see, the average speed is v2, distance is d2, and time is t. So d1 by t is v1 and d2 by t is v2. So this becomes half of v1 plus v2. That is the answer. This is the answer. The average velocity will be v1 plus v2 by 2. You can write like this. So this is an important lesson to understand, students. Whenever the average speeds are given for a half of the times, the net average speed is v1 plus v2 by 2. But if they are given for half of the distances, then the answer in previous question we have seen is 2 v1 v2 upon v1 plus v2. Okay, so I suggest you to please understand the difference in these two questions. Let us proceed to solve some more questions. The next one is a graphical question. Figure shows a VT graph for three particles A, C and B. You have to compare small a, that is acceleration for the three particles A, B and C. Now we have to find acceleration and we are given VT graph. You know that slope of VT graph gives what, students? It gives acceleration. We have to compare their accelerations, that means we have to compare their slopes. Out of these three, if you remember, I have discussed, if you sit here, you will fall with greater acceleration. The angle which it makes with time axis is maximum for A. So we say slope of body A is maximum. It is greater than other two. Now if you compare C and B, which is greater? Of course C. So this is greater than slope of C and that is greater than slope of A. But slope of graph, VT graph, gives acceleration. So instead of slope, we can write acceleration. These are the slopes for velocity time graph. That means acceleration of particle A is greater than particle C and that is greater than acceleration for particle A. So this is the answer to this simple question. Okay. This is fourth question. The question is this, that a racing car has uniform acceleration of 4 meters per second square. What distance will it cover in 10 seconds after start? See, in the beginning, students, for solving such numericals, please note down the important things that are given in the question. For example, acceleration is given how much? 4 meters per second square. Underline it. This time is given 10 seconds. What we have to find? We have to find distance, and most of the questions will have a straight line motion like this. So the distance and displacement will be same, so you should not bother about that. After start, whenever a body starts, the racing car starts, before starting or just during start, it starts from rest. That means initially it was at rest. It starts from rest. If it starts from rest, that means its velocity was how much? 0. Which velocity was 0? That was initial velocity. So these are the three things given. So one by one we should write them. So let's see. So let's see the given things. The initial velocity is how much, students? Because it starts from rest, initial velocity is 0. What is the symbol for initial velocity? U. So U is equal to 0. Acceleration is given, students. A is equal to how much? 4 meters per second square. Then time is given, t is equal to 10 seconds. And what we have to calculate? Distance, but I told the distance and displacement will be same. So we have to find S. Out of the 4 equations of motion, which of them will be suitable for finding S? So you can see S, U, A and T can be related using this relation. S is equal to U times T plus half A T square. Out of those 4, you have to choose one equation. So that is the answer method. So you put the values. U is equal to 0. So 0 into something will be 0 plus half times A. A is 4 times T square. T is 10 square. So 10 square is 100. 100 and this becomes 2. So 200 meters is our answer. Is it clear, students? Now if you have some problem in remembering this particular formula, not remembering, in thinking that which formula we should use, see, you have the collection. V is U plus AT, S is UT plus half AT square, and V square is U square plus 2AS, and one more is there, S is U plus V by 2 into T. I am going to say something which will help you, students, if you are finding it difficult to think which equation we should use. See, there are 5 things. One is U. So we have finished this question. Just I am discussing something which will help you out. There is U, there is V, there is A, there is T, there is S. How many things are there? You can see 1, 2, 3, 4 and 5. In any one equation, if you choose, you will find that there are only 4 of the given parameters. For example, you see this one. V is there, U is there, A is there, T is there. So what is not present? In first equation, S is missing. Here we don't have S. Likewise, can you think what is not present in second equation? S is there, U is there, T is there, A is there. What is not present? V. V is there, U is there, A, S, all are present. What is not present? T. And here A. Is it clear, students, what I am discussing? Now you think, in a given question, what is given and what you have to find. You are given U, A, T and you have to find S. So you have to find a relation between these 4 quantities. U, A, T, S. What is missing, students, here? There are 5 parameters. U is there, A is there, T is there, S is there. What is not present? V is not present. Out of these, in which of the equation V is not present? V is not present in this particular equation. That's why we have used S is equal to UT plus half AT square. See, in the beginning this might be helpful, but I am sure if you practice few questions yourself, then you will not need such tricks. You will be able to solve the questions by recalling the correct equation for motion. So let's see some more questions. Okay, here we have the next question. That brakes applied to a car produce an acceleration. Again, acceleration is given, so we will underline it. How much it is given? 6 meters per second square. Another important thing is given, that this acceleration is in opposite direction to the motion. It is opposite to the direction of motion. See, brakes are applied. Suppose there is some car. So this is the car. This is the car. It is moving in this direction. It has some speed. Now if it applies brakes, it produces acceleration in opposite direction. Since acceleration is in opposite direction, this we also call as retardation. So on applying brakes, what happens? Speed decreases. So when we apply the brakes of a cycle or car, speed will go on reducing and it may become zero after some time. It was traveling with some velocity, then after some time it comes to rest. Its velocity becomes zero. Initially it had some velocity which we'll write as u. Finally it comes to rest, so its velocity becomes zero. What is important to note is that the direction of motion is towards right. If we take this direction as positive, the left direction will be taken as negative. Remember students, vector quantities in one-dimensional motion can be given plus and minus signs. So plus if you are taking to the right, minus will be to the left. Since the acceleration direction is opposite to the direction of motion, so motion means velocity. So velocity and acceleration in this question must have opposite signs. Initial velocity and acceleration must have opposite sign. Then what important thing is given? It takes 2 seconds to stop. Stop means it comes at rest. Calculate the distance it travels. You have to find this distance s. So what are the things given? You are given acceleration, you are given time, and you are given final velocity because it stops. So final velocity is 0, time is 2 seconds, and acceleration is 6 meters per second square. If you write, it will be wrong because I told the motion is in positive direction. Acceleration is opposite to the motion. So we will take it as negative, and you will write negative sign indicates retardation. It indicates retardation. Just as we have acceleration, similarly we have retardation. Just the sign is opposite. Acceleration generally we write if we have plus 6, and retardation we will write if we have negative 6 meters per second square. Now what we have to calculate? We have to calculate s. Displacement is equal to question mark. Now we are given a, t, v, and we have to calculate s. So which formula we can use here? You have to think what is missing here. Here the missing thing is u. So which is the formula without u? Without u the formula is we can do it directly actually. So a, t and v means first we find using this relation u. So v is 0, put 0. U is not known. A is minus 6. T is 2. So this becomes minus 12. That will come this side. So our U becomes how much? 12 meters per second. And then you can calculate S is equal to any formula you can use. You can use ut plus half at square, or you can use v square is equal to u square plus 2as, or you can use s is equal to u plus v by 2 into t. In all the cases you will get the same formula. So just check it out. So this becomes how much? U is 12 into t. T is 2 plus half a is minus 6 into t square. So t is 2, so 2 square. So you can solve this yourself, students. That will give you the answer in meters. So our final answer becomes 12 into 2 is 24, plus minus minus, so 1 2 will cancel, 6 into 2 is 12, so 24 minus 12 meters, that is 12 meters. So the car would travel a distance of 12 meters before coming to rest. So let's see next question. We have a question here that goes like this: a car starts from rest. So important things will underline, students, as usual. It starts from rest. That means its initial velocity must be how much? It must be 0, because it is starting from rest. It accelerates uniformly for 5 seconds. So our time becomes how much? 5 seconds. After 5 seconds, it attains a velocity of 50 meters per second. So this is our final velocity. So final velocity is 50 meters per second. And we have to calculate what? We have to calculate the distance covered. S is question mark. Now can you think of a relation to solve this question? I will try to solve it using two methods. First, like previous question, we'll first find acceleration. First step will be to use this relation, v is equal to u plus at. So our v is 50, u is 0, a we have to find, t is 5. So 5a is 50, so this implies a will be 50 by 5, that is 10 meters per second square. So once we get the acceleration, after finding acceleration, we can easily calculate the displacement. So s is equal to ut plus half at square. So this becomes how much? So put the values of ut and a. So u is 0, so this will become 0. So we are left with half times a. A is 10 times t square. T square becomes 5 square. So 2 5s are 10. So 5 square is 25. 25 into 5 is 125 meters. So that is the answer to this particular question. So this is your method 1. Let's try to solve it using other method, method 2. What we can do here, we can directly use one relation, that is s is equal to u plus v by 2 into t. If you remember, students, I have told you to remember that fourth equation of uniformly accelerated motion which I am using here. If you use this relation, you need not find acceleration. So it will have only one step. Let's check the answer. So u is 0, v is 50 by 2 into t. T is 5. So 50 by 2 is 25. 25 into 5 will again give how much? That is 125 meters. So we find both the ways give the correct answer. Instead of using this formula, you can also use other formula. V square is equal to u square plus 2as. I suggest to you, students, please do not cram the methods. Do as per your ability and as per your thinking. So today I discussed some of the important numericals, and these will help you to understand the concepts, and based on these some assignments are given. Apart from that, you would also do some questions from the textbook. So I am giving some homeworks to you. So please note down these homeworks and do in your class note. You will see NCERT page 108. See if it is old NCERT, if it is new NCERT, there may be variation in page numbers, but I am using the new one. So page 108, examples 8.5, 8.6, 8.7. These are examples. Just I am giving the hint. 8.5, not hint, I am giving the question. 8.5 is a train starting from, this is related to a train. Why I am saying this? Because if the page numbers don't match, You can guess from this. 8.6 is related to a car. 8.7 related to brakes applied to a car, etc. So this is number 1. Next homework will be your blue ink questions on the same page. Blue ink questions on page number 109. Please do these questions yourself. So here we have questions 1, 2, 3, 4 and 5. So these 5 and these 3, these 8 questions you try, students. Apart from that, if you wish, you can try some other questions from other texts also, and you can put them if you are having some doubts in the query list. I wish you all the best. Next class we shall discuss uniform circular motion, and that will be the last topic of this particular chapter. I thank you, students.